This project provides a framework on how component-based development approach addresses the challenge of various user preferences in a home security system by demonstrating the method in different implementation scenarios. Each of these implementation prototypes followed the CBD model presented in the study. In this fifth implementation option presents the integration of the four implementation prototypes previously presented. This provides a single system with multiple subcomponents. Each of the subcomponents presented already have been built out of components, both hardware and software. The software follows the framework that can easily be reused and integrated into other systems. As we already know, the Arduino microcontroller provides the capability and flexibility to accommodate as many sensors and functions that it can fit. For this integrated implementation option, we have 9 major subcomponents grouped together by microcontroller assembly. First is the main component that receives and relays data signals from other components. It is fitted with a 2.4 GHz nRF24L01 module. We reuse this assembly from scenario number 3 as connected to the next component through an I2C bus. The web relay component receives data from the main component and sends it to a predefined web application as we have used in scenario 3 and 4. We'll cover the web application in a little while. Next is a component 51. It is initially intended as an independent tester for gas sensors. Reusing it, it can be connected to another component through I2C or fitted with an nRF24L01 module as with the other components. Next is component 52. It's the component we use in the kitchen safety implementation scenario. It includes fire, smoke, water, temperature, and humidity sensors. To be integrated into this large system, it is fitted with a wireless module. This subcomponent is intended as an early warning device for fire and water incidents. Fifth, component 53. Also from the kitchen safety components is component 53. It is fitted with 2 gas sensors, MQ3 and MQ4, and a relay switch. The MQ3 gas sensor detects smoke, alcohol, and ethanol, while MQ4 gas sensor detects methane and combustible natural gases. To dissipate and disperse the detected gases, the relay switch can be used as conduit for home appliances and high voltage equipment to be added into the system. An example could be a fan or an exhaust fan that dissipates or disperses the detected gases. The relay switch will turn on the appliance held in an idle mode. The component is programmed to power on the appliance and stay on for a number of seconds before the reading of the gas sensors are refreshed or restarted. This is to allow time for the dissipation and dispersal of the detected gases within the cycle. Next in the list is component 54, reused from our perimeter security implementation scenario number 1 that monitors movement or intrusion surrounding the home. It is fitted with an ultrasonic sensor, infrared sensor, reed switch, hall switches, and a light blocking sensor. The ultrasonic and infrared sensor monitor movements from a distance, while the reed switch, hall switches, and light blocking sensors for close proximity objects. The magnetic switches and light blocking sensors can be attached to gates or doors that can be triggered when opened or in any scenario if closed. As a notification, a buzzer and LEDs are also attached. Next, the seventh component, component number 55 or 56, is reused from our entrance or exit security that monitors movements through shocks and magnetic attachment or detachment mechanism. A relay switch provides the system to control another appliance like lights or any high voltage equipment as needed. Flexibility is considered for the homeowner to consider when deploying the system. A buzzer and LED bulbs are also added as part of the notification. The eighth component, component 57, is repurposed from our living spaces safety, which includes an ultrasonic sensor, a gas sensor, and a humidity sensor. Alarm levels are independently set for the different sensors, which activates the buzzer and LEDs when triggered. Components 54, 56, and 57 can be reused, duplicated, or modified to accommodate the various user needs and preferences. The three components are interconnected through I2C bus, two-wire as data and clock, and ground. Component 55 monitors the signal by asking each of the component with their respective status. Signals from component 54, 56, and 57, acting as slaves, are received by component 55, acting as the master. Component 55 then relays the signal to the main component wirelessly through the NRF24L01 module. The main component waits for signals from the different components. Any signal it receives is relayed to the web relay component. The web relay component sends the status to a web application on the internet. The web application stores the coded status in its database. The web application can be separately programmed to deal with the data in storage. In this demo, we are only presenting the status as text, while the data is stored in a database, and as it follows an entity relationship structure. Further improvements can be done, leading to a much bigger integrated home security system. An application programming interface can also be added into the system, which allows other systems to read the data from our web application. Each of the subcomponents already offers flexibility and expansion in terms of capability and also coverage depending on the sensors or needs of the homeowner. With the integrated system, more subcomponents can also be included. The components as presented in the study can be connected through I2C bus or wirelessly through a 2.4 GHz module.